Hello, good evening. So today my topic is about the law of conservation of energy. This topic is included in the ninth class physics subject. I think that is in sixth chapter. So today I'm explaining law of conservation of energy. First of all, let me explain the basic statement of law of conservation of energy. The statement shows that energy can be converted from one form to another form, but it neither created and nor destroyed. And secondly, we can say that in the whole universe, whatever the amount of energy is present and created by God, so neither we can create it nor we can destroy it. So we can just convert energy from one form to another according to our requirements. So now I'll verify mathematically that how energy can be converted from one form to another form. So for this example and verification, we have to take one object that is placed above the surface of earth at point A. Let me draw the diagram of this object. Just imagine that this is an object. Its position is A, that is above the ground, and it has a height from the surface of the ground, that is h, and on the surface of the ground the object is placed, that is point C, whereas in between them the object is placed at any point. We can give them a name as B. Now at point C, we consider C as the ground surface, ground surface, and the height from the ground surface at point B, this will be considered as h minus h dash, because we take the height from B to A, that will be h dash. So the sum of h dash and h minus h dash is h, because one is plus h and the second one is minus h. So plus and minus will be cancelled, so the remaining h will be the height from the surface of ground to position A. Now for considering the verification, we have considered three position A, B, C of an object. One is ground surface, the other is some a little how above the surface of earth, that is B, and the third one is more than surface of earth, that is A. So now we will consider the total energy at point A. So we can write the total energy at point A will be equal to kinetic energy at point A plus potential energy at point A. As we know that kinetic energy at point A is 0, because there is no motion. The object at point A is at rest, so its initial velocity is 0. When the velocity is 0, it means there is no motion. So no motion means that there is no kinetic energy, because kinetic energy is concerned with an object having some motion. But as the initial velocity of an object is 0, it means that there is no kinetic energy, but it has some potential energy. So let me explain that what is the amount of potential energy. According to formula of potential energy, we know that potential energy is the mass of object, gravitational acceleration, and the height of the object from the surface of earth, that is h, because at point A the object is placed uh, on the surface of earth at height h. So the total energy at point A will be equal to kinetic energy plus potential energy. I mean the sum of these two energy but as we know that there is no motion at point A, so the kinetic energy of the object is 0 because of initial velocity 0. Now this was the total energy of an object, so we can write the total energy of an object A at point A will be mgh. Now the total energy at point B, we can write total energy at point B is equal to, just like above we have already written, kinetic energy at point B plus potential energy at point B. But before explaining these kinetic and potential, let me take some steps. As the object is moving from point A to point B, but at point A the initial velocity was 0 and the object displaced gravitationally from point A to point B, and it displaces the displace up to how much point? H dash. So with the gravitational acceleration g. So according to third equation of motion, we can say that 2as is equal to vf square minus vi square. So at first initial velocity was 0, but the final velocity was v. So according to third equation of motion, we can say that 2as is equal to vf square minus vi square. So we use this third equation of motion for horizontal motion, but the object is not moving in horizontal, it is moving in a vertical position. So 2 will remain 2. So a will be converted into gravitational acceleration and s will be converted into h dash, because the distance covered by object from point A to point B is h dash is equal to, so we can write final velocity will be v square minus initial, as we know already it is 0. So the equation will become v square is equal to 2gh. Just keep in mind this equation, because we have to put later this equation in the instead of kinetic energy. Now put the value total energy at point B is equal to kinetic energy. So kinetic, we know that half mv square plus potential energy, because the mass has not been changed, so mass will remain m and g will be just like g, because gravitational acceleration will remain same, but the h will be mg h dash. Sorry, h will not be, because now the h from the surface of the ground to point B is h minus h dash, so it will become h minus h dash. Now total energy at point B will be equal to half m. So instead of v square we will write 2gh 2gh dash, sorry, 2gh dash plus mg will be multiplied with both these terms. So first will become mgh and minus mgh dash. So in the next step 2 and 2 will be cancelled. So mgh dash plus mgh minus mgh dash. So in these three terms we can see that one is positive, one is negative, so these two will be cancelled. So the remaining one will be mgh. So it means total energy at point B is again mgh, because we have studied in the first statement that energy can neither be created nor destroyed, but it can be converted from one form to another. And secondly, the total energy remains constant at any point. Now we are going to the point C. So at point C, the total energy at point C will be equal to kinetic energy at point C plus potential energy at point C. Here we will take the another step. From point A, the object was moving towards point B. So we take the initial velocity as 0 at point A, but at point B it was V. And we derived the equation at point B, the total energy was mgh. And at point A it was also mgh, because there was complete potential energy but there was no kinetic because of initial velocity 0. Now we will consider that the object is moving directly from point A to point C. It is displacing at h, with h from point A to point B. At point A the initial velocity is 0, but at point C the initial velocity, we can say that with V. So the final will be V. Initial at point A is 0, so final will be V. With V velocity it moves from point A to point C and cover the distance of h. So let me take kinetic energy. We already know that the formula of kinetic energy is half mv square plus, so here I'll write directly potential energy as 0, because they on the surface of earth h is 0, so m and g has some values, but because of h is 0, so the total term will become 0. So according to third law of equation, let me take the value of v square as well again, and then I'll put it here, so it will be derived, so the value of mgh will come again, because we see that the total energy at any point remains constant. Now at point A the initial velocity was 0, and at it moves from point A to point C with a gravitational acceleration g, and at point A the initial was 0, but it moves with a final velocity vf, that is equal to v. And at point C, when it is reaches to point C, so it has total kinetic energy. So at point C, let me derive according to third equation of motion, that is 2a square is equal to 2as is equal to vf square minus vi square, as I explained already earlier that this equation is used for horizontal motion, but we need it because the object is moving vertically, so 2 will remain 2, and a linear acceleration will be converted into gravitational acceleration, so h will be converted. So we can say that this is complete h, because from A to point C it is complete distance h is equal to, because vf is equal to v, so it will become v square minus 0. So same equation will become v square is equal to 2gh. Now put in this equation, so total energy at point C, total energy at point C will be equal to half mv square, because the potential is already 0, so half m, so instead of v square I will write 2gh, so 2 will be cancelled, so mgh. So at point A we derived a formula that at point A the total energy will be mgh. Similarly at point B the total energy will be mgh. Similarly at point C the total energy will be mgh. So it is mathematically verified according to this verification and derivation, that the energy can neither be created nor destroyed, but it can be converted from one form of energy to another form, but the total energy remains constant if we take at any point. So I just took it 3 point A B C, so derived at point A, at point B, at point C, so the total energy at each point is equal to mgh. So this was the law of conservation of energy according to derivation and verification of an object. That's all. Thank you so much.